Good morning friends. In the last session we have seen the overview of our 1500 kV air control panel power diagram and a control diagram. So here there is one main incomer which is feeding to the copper bus bar systems. Bus bars are the copper flat bars. It is used instead of wire, flexible wires due to some technical reasons. Then from the bus bar there will be one branch breaker Q1. It will be Q1 will feed to three set of contactors K1.1, K1.2, K1.3. Again with each contactor will feed two capacitor banks parallel to each other. And here it is 25 kVAr, 25 kVAr, total 50 kVAr. Designation is 1C1 and 1C2. The second set is K1.2 and it is feeding to 1C3, 1C4, 50 kVAr, 25 kVAr each. The third set is K1.3, it is feeding to 12.5 kVAr each contactor capacitor banks. And designation is C1, C5, 1C6. For the other branch circuit branches, we have represented in a single line diagram form. The breakers are Q2 to Q12 and the contactor and the capacitors are designated accordingly. Coming to the control circuit, we have our 480 volt system. But since some components are wired onto the door like push button pilot lights, this 480 volt cannot be used as a control voltage, because by some accidental contact, if you get somebody come in contact with any live parts, he will severely get shocked. So we have to reduce the voltage to a safe limit. So our control voltages are 230, 110, 48, 24, AC or DC, depending on the system requirement. So here we have one control transformer 480 to 30 volt. It is connected to phase, either RY or YB or BR. Then in the primary there will be one fuse protecting the coil of this prime contactor transformer, and secondary there will be one fuse. So here the output will be 230 volt AC. This is phase and this is neutral for the control system. Now there will be one auto manual switch. In auto mode, when the switch turn to right auto mode, power come to here, and there will be one controller contact inside the controller. Depending on the signal, it will be switch on, is it closed or open. So when it close, the power come here, and all the this contactor coils are get energized. So contactor is like a magnetic switch. When this coil gets applied, it magnetic field forms and it pulls a moving part. So one fixed part and moving part are get closed here. So and since there is a pilot light parallel to the coil, so it gives indication that the contactor is switched on. So obviously it is when the contactor switched on, the capacitor will be charged. So this PL1 when glow, it will give indication that capacitor banks are on. In manual mode, when switch is turn to left, the supply come here, and then it pass through a stop push button or a open push button. It will have a normally closed contact. Normally closed means in normal condition it will be, this contact remains always closed condition. And this is one closing push button. This is normally open contact. These are all spring operated. So when you press this, the current come here and come to the this contactor gets supplied. But when you leave this switch push button, this contactor gets off. So to latch it, we are using one NO contact of this contactor as just a latching. The function is like this. When you press this button, this energizes, and the auxiliary contact is some contact of it is some auxiliary contact. It closes when the coil gets supplied. This also closes, and now current carries this path and this path. So even when you leave this push button, the current continue in this path. So it remain in the closed condition. If you want to break the switch, break the path, you have to press this. If you press this, then this will not close automatically unless you press it. And there is a center of position, automatic switch of center of position. When you want to de-energize the system, if you don't want to operate in either auto or manual mode, you can put in center position. Or if you want to make some maintenance or repair work, you can put this in center position. And for others the same principle, but here the switch is gang operated. When you turn the switch to manual mode, all the switches will be turned, all the contact will be changed to manual mode or auto mode. And here this is the general representation for circuit Q PL2 to 12. So pilot lights are represented by PL2 to PL12. Now in the next chapter we will see the wiring diagram of the controller. This is the typical diagram of a controller. So here our supply voltage is 230 volt AC, control supply. Now this controller have options for 400 volt, 230 volt, 110 volt, and 0 is common. We have to apply the voltage depending upon availability. Then there is 2 points K and I. This is crucial because these 2 points receive the signal from the main panel, main system. Main system means suppose this is your main panel. It has feeding to blower, water pump, lift, lighting, a workshop, exhaust fan, all the loads. So some loads are like blower, water pump, all have or inductive loads. So depending upon the operation of these loads, the power factor, the current, nature of the current is the lagging because of inductive load. So depending on the load, this will give these are the current transformers for metering of this panel, but there will be one CT, fourth CT current transformer. This will feed to this point K and I. So this is a comparator. Inside we have to put the target power factor 0.98 or 97 or 96, and the comparator will compare the nature of the power factor of the system, and it will give signal to close these contacts 1 to 12. So depending upon how many kVARs required, these contacts are closed or open. Suppose the load is some loads are switched off, then the power factor improves. So in that case, some capacitors are switched off automatically depend by these controller contacts. Here this point A is for supply is coming from here because the current should pass through the contact and come to this is a relay or contactor. Some cases if the contactor size is small, it directly feeds the contactors, and if some cases if the contactors are big size or there are more than more contacts, like in our case we have 3 contactors in parallel. So the load comes to this point. In that case, this contact will burn, and since it is inside the contact, we cannot repair it. In that case, so to avoid this, we are using one small relay. It will have only small auxiliary contacts, and this contact will not damage, and this NO contact will energize the main contactor, big power contactors. This is called capacitor duty contactors, because there are many types of contactors: lighting contactor, for motor switching contactor, but this is special type, so this is called CDC or capacitor duty contactors. Now in the next topic we will see use of reactors, detuned reactors. Okay. So this is the overview of our system. The left side upper portion is a power diagram, lower side is control diagram, and right side is a controller diagram, and extreme right side is main panel. In the next topic we will discuss about the detuned reactors and the creation of bill of material for this panel. So this is the electrical equivalent of or electrical diagram equivalent of the logic. In our electrical diagram, we have one auto manual switch. So here, this is the auto. This is the one. This is the manual. Now, when we close this auto manual position, one lamp is running, glowing. This is indicates the manual mode is on. Then when we close this, when turn the switch to auto mode, this lamp is indicating auto mode. And in manual mode, we have seen, we have now, this is our switch. When you turn this left, the contact block is this side. This is giving power going to this. But turn right, this auto mode is running. So always there will be in either auto or manual. So here that one we represented by one interlock, means if you try to close the both switch, you see what happens. Now this is in manual mode, so one on, and then this auto mode on. When I try to close, when auto is on, I try to close this. You can see both the off, because the current is blocking up to here. Red line means there is a blocking current. Blue means there is no current. So because of interlock between these two, the line is blocked here. Okay, then we have our push buttons. We have our, for manual mode, we have push buttons. We are represented by, so suppose we will put this in our manual mode, we will see all the manual modes are closed. Here one, this is a 4-stage controller. So there will be 4 stage only, Q1, then here 1 second stage. This is 3rd stage. And this is 4th stage. So you can see all the manual modes are on. Now we will switch on the capacitors one by one. Now this is manual mode. I will close this. So by push button, there is one contactor in our electrical circuit. This electrical circuit, when we close this push button, this contactor energizes, and because this contactor is closing one capacitor 10 kVA, 10 kVAr. So this is our output. This is 10 kVAr capacity switched on because of the first set. Now coming to second set. Now we will close this. So this again contacting closing contact K2. So our second capacitor is 15 kVAr, which is switched on. Now coming to 3rd stage. I am closing this. So contactor closing, contactor is closing the 20 kVAr capacitor. So 3rd capacitor is on. Now coming to fourth stage, this is the one using K4 and K1. So now all the capacitors are in manual mode. Now I will switch off one by one. So for that I will switch off this push button off, fourth gun, the third gun, second gun, first gun. So this is the manual operation of the push button and contactor and capacitor. Now we will reset all. Now we will turn the switch into auto mode. So this is your auto mode. This is your auto mode. Now turn the color auto, and this is also showing auto mode. Now this is in our diagram. You can see there is these are the push buttons. When you press this, wire is connected here. This is spring operated. This will be closed momentarily, and this is one for this is one NO contactor. This one NC contactor. So this is on off. Then these are the contactors which control which give supply to, which give power to the capacitors. This is a special duty contactor called a capacitor contactors. These are the pilot lights which indicates on or off indication. These are the capacitors. Now this is the controller, which is the heart of the system. If you will see backside, there will be one switching devices. There are some switching devices. Depending on our requirement, these are these are give a signal to close the contactors, to close, open or close the contactors. So now in our system, we will consider this as auto contact one signal. Suppose the signal came to switch on one 10 kVA contactor, so this will close. This controller will give. Now you see this 10 kVA capacitor is on. Now suppose the demand requires more, additional 15 kVA. So the second contactor will close from the controller. Now you see one 15 kVA capacitor is on now. Now is 25, 10 plus 15. Now still you need 20 kVA. So what I will do, this controller give 20 kVA. Okay. Now this is a 10, 15, 20. 10 plus 15, 25 plus 20, 45. 45, then you need still 25. So this will close. Now all capacitors 10, 15, 10, 15, 20 and 25 all are on. Now suppose some inductor loads are switched off, like a blower or pump or some lift, or switched off escalator. Then power factor improvement means, suppose you need to reduce your capacitors one switch off. So here switch off is controlling C controller 1. So this contactor will open. Now still some further loads are closed, stopped. So we need to switch off 115 kVA capacitor. So controller will give command to switch open this contact. Still you need, so by this we can switch off, automatically switch off all these contacts. So now only all are switched off. So this is the how the controller works.